we can visualize this process according to the probabilities. Okay, here's the tree diagram. We have a king or a queen or a jack. Then we have, now I'm listing only the possibilities that give us exactly 2 kings. Okay, so we can go king, king, queen, queen, king, jack, king, queen, king, or jack, king. Those are the 6 ways that we listed on the above diagram here to get exactly 2 kings. Sorry to have to cut this section in half, but the phone rang. Didn't want to leave that going on. Okay, now on each branch here we're going to list the probability. So to get a king, there's a 4 out of 12 probability on the first card. A queen on the first card is 4 out of 12, and a jack on the first card is 4 out of 12. Then to get a king on the second card after getting a king on the first, there are 3 kings left in the deck and 11 cards, so the probability would be 3 out of 11. To get a queen on the second card after a king on the first, well, there are 4 queens and 11 cards left. To get a jack, again, 4 jacks out of 11 cards, so there's our probability. If we move over then to getting a queen, well, after king, king, we could get a queen, probability 4 out of 10, there are 4 queens left out of 10 cards, or we could get a jack, 4 jacks left out of 10 cards. Now the probability that we get out of that is the probability that we get if we multiply the 4 twelfths by the 3 elevenths by the 4 twelfths. That's what we get from the first row. 4 times 3 times 4 is 48, 12 times 11 times 10 is 1320. So it's 48 over 1320. Similarly for the king, king, jack. The numbers are exactly the same, it's just that we have a different event. So we have another 48 out of 1320. Now if we look at the king, queen, king, it's 4 out of 12 times 4 out of 11 times 3 out of 10. Okay, so if we multiply 4 out of 12 by 4 out of 11 by 3 out of 10, well, we really have the same numbers in the numerator that we had up here. 2 4s and a 3. They're in a different order, but we know that doesn't make any difference. And the denominator is 12 times 11 times 10, so again we have 48 over 1320. And in every other case it's the same. We have 4, 4, and 4 and 3 in the numerator, 12, 11, 10 in the denominator. Every time when we multiply the probabilities, so that in every case we have the same numbers. This 4 here is an error. This should be a 3. Cross out that 4 and make a bad looking 3. Because here we've gotten a king. There were 4 kings at this point. There are only 3 kings left at this point. In any case, in every event, every one of the 6 events, we get 48 out of 1320. And that happens 6 ways, 48 out of 1320 each. We could multiply these up and then get the probability, which is going to be 288, I believe, out of 1320, and that'll reduce. Another way to analyze that is to say the probability of getting 2 kings. How many ways are there favorable to getting 2 kings? Well, it's a number of ways of getting 2 kings. Over the total number of ways, we could get 3 cards out of the 12. Knowing what we do about permutations and combinations, the number of ways of getting 2 kings, what do we have to do to get 2 kings? We first have to get 2 kings out of the 4, so there are how many ways to do that? We pick 2 out of 4. Combination, 2 out of 4. That's how many ways there are to get 2 kings, and we multiply that by the number of possibilities we have on the third card, which means we have to choose 1 out of 8. Okay, so we have a combination 1 out of 8 there. And we divide that by the total number of hands that we could get, which means that we choose 3 cards out of 12. So it's combination of 4, 2 times combination of 8, 1, divided by combination of 12, 3. And we can reduce that down and see that it gives us the same thing that we get up here. And you should check that out.